Hello, everyone. Welcome to our webinar to discuss the MANTIS flare monitor. Appreciate you joining us for this webinar. What we're going to cover is we're going to introduce the method behind the MANTIS flare monitor, which is VISR. We're going to talk about some of the validation testing that's been done on this method, some of the benefits and applications of this method for flare monitoring. And then finally, we're going to give a demonstration what the flare monitor looks like in action. First, the method that's built into the MANTIS flare monitor. MANTIS is based on a video imaging spectral radiometer, or VISR. So VISR is an acronym. Each word in the acronym has a meaning for this particular type of imager. So video describes the fact that we're capturing these images at a high frame rate. In our case, it's 30 hertz. Imaging, in the sense that we're producing a two-dimensional image with two spatial dimensions, and in the case of VISR, a third dimension, which is spectral. Spectral meaning we're looking at different slices of the infrared spectrum. The VISR operates in the mid-wave infrared, and we're looking at multiple spectrums simultaneously in the mid-wave infrared. And radiometer means the device itself has been radiometrically calibrated. So with the VISR imager and the method we built around it, we can use this to directly measure the relative concentrations of the combustion products for an elevated flare. So specifically, we're looking at the CO2 and the unburned hydrocarbon. And the ratios of these two can tell us how well the flare is burning. We can do this in real time. We can make this measurement 30 times a second, and VISR will actually produce a combustion efficiency number every 1 second. It's important to note that what VISR is doing is directly measuring the combustion efficiency. The current state of the art is to apply indirect methods, which is to measure everything you're sending to the flare and use those measurements to calculate a combustion zone net heating value. That, along with the flare tip velocity, if you maintain certain levels, you can assume you have good combustion. We would call that an indirect method. What VISR is doing is directly measuring the post-combustion gas and directly calculating the combustion efficiency. So what sort of information can you get from a VISR device about your flare? I have 5 performance parameters that we calculate. The first is the combustion efficiency. So this will be a number from 0 to 100%. If you have 100% combustion efficiency, that means all of the hydrocarbons have been converted into CO2. And to the degree that your combustion efficiency falls below 100%, that's an indication of what percentage of the hydrocarbons have not been combusted. So, for example, in the refinery sector rule, the compliance standard for a flare is 96.5% combustion efficiency. So this would be the number from VISR that's compared to that compliance standard. Smoke index is a unitless number from 0 to 10, which indicates the level of smoke or particulates in the combustion plume. So this will be an indication of whether you have visible emissions coming from the flare. I'll show you some examples of that later. Third parameter is flame stability. This is a number from 0 to 1, which indicates the stability of the flame in terms of radiance, how the radiance is changing over time. So if you have a very stable burning flame, the radiance will be fairly constant and this flame stability will be quite high. If you have a pulsing flame, maybe an oversteamed flame, where it's being quenched and reignited, then this flame stability will be very low. Flame footprint is simply a cross-sectional area perpendicular to the VISR line of sight, which represents the combustion plume. It's typically larger than the visible plume if the flame itself is visible. This is really looking at the flame and the post-combustion gas. And finally, heat release, which is the amount of heat released by the flare in the spectrums that we're monitoring with VISR. So this will not be the total heat release from the flare, but it will be this number, this heat release number will be well correlated to the total heat release from the flare. But we're not actually measuring the broad spectrum heat release. We're just looking at the slices, the midwave that VISR is monitoring. So all 5 of these parameters are provided with a 1-second temporal resolution. We can also, with VISR, do the averaging to get 1 minute and 15 minutes. But the base interval of all 5 of these is 1 second. And this data is provided with no latency. So it's immediately available for consumption either by DCS or PLC or a user interface provided with VISR. So these performance parameters calculated in real time with no latency, it's very well suited for a control loop. And so a VISR system can actually put into closed loop control and used as a feedback system to enable automated control of optimization of your flare. To give you an idea of what VISR looks like. So here we have a user interface that's showing the real-time 1-second data from a VISR test. The videos playing on the right, on the upper right-hand side, that's a visible spectrum video. This is one of our validation tests. The flame's actually not visible, but you can see a crane is holding a extractive sampling system above to extract the combustion products. The VISR multispectral image is on the bottom right. You can actually see the shadow of the inductor, and then the 5 performance parameters are shown on the left side there. Some other examples of what VISR looks like. In this case, we're focusing on smoke index. On the right side, you can see that we have no visible emissions, and so what we're seeing here is a very low smoke index. And if you look at the multispectral image, see it's nice and orange and yellow, and the red in this is really a false color multispectral image where we've assigned the CO2 band to red, the hydrocarbon band to green, and when you see a whitish, bluish smoke, that is an indication of particulates or solid particles that have broad spectrum radiance. And so this is just meant as a visual indicator of the data that VISR is streaming. So the image on the right, no visible emissions, bright orange, a multispectral image, low smoke index. On the left, you see this flame is smoking, and VISR is calculating the smoke index. And in this test, it was between 5 and 6. We've done quite a lot of validation testing for this method. Extractive sampling is the control method that we use to validate our results. In total, we've done 72 individual tests using extractive sampling as a control. 28 of these were done at Zico's test facility in Tulsa. 45 were done at John Zink's test facility, also in Tulsa. Those 45 done at John Zink were part of a blind test sponsored by PERF, which I'll go into here in the next few slides. But the point I want to convey on this slide is this method has been exhaustively and extensively tested and proven and demonstrated using an extractive control method to show that it's quite accurate, well within 1% of the extractive sampling result. The PERF test was probably the largest validation study for this particular method. If you're not familiar with PERF, it's an industry group. PERF stands for Petroleum Environmental Research Forum. It's an industry group that gets together and funds research into new technologies for a variety of applications in the petroleum sector. This particular study was funded by ExxonMobil, BP, Chevron, Phillips Chemical, Eastman Chemical, Phillips 66, Saudi Aramco, and Shell. So these companies got together and funded a test. Their funds went to set up a blind test at the Johns Inc. testing facility with extractive system and used as a control method. And then participants were invited to come to the test and use remote technologies to measure the flare combustion efficiency. It's a total of 45 tests. Each was 70 minutes long. And again, the extractive method was used as a reference. Covered quite a wide range of fuel types, from natural gas to propylene nitrogen blends, natural gas hydrogen blends, all the way up to 75% hydrogen. Fuel flow rates all the way from 100 pounds an hour up to 10,000 pounds an hour. And steam ratios anywhere from 122 up to 600 BTU per scuff. So quite a wide range of process conditions were covered during the 2 weeks of this perf test. And I should mention this test was completely blind. So the fuel type, fuel flow rate, steam ratios, none of this was provided to the participants. They were asked to provide the combustion efficiency blind without knowing anything about the process condition. As I mentioned, this test covered 2 weeks, so we were exposed to a variety of environmental conditions, different temperatures. Tests were done during the daytime and nighttime. Some of the objectives of the test had us do tests at various viewing angles between the VISR system and the flare. So we looked at crosswind conditions, upwind conditions, downwind conditions. We looked at a range of distances from 174 feet up to 650 feet. The plot that you see there is showing the test facility. The flare is roughly in the center of that image, and each of the circles with numbers, those are different positions where VISR test data was taken. We would move the VISR system around depending on the conditions to get the desired test condition, such as crosswind or downwind. We experienced rain during this test, fog. One of the test objectives was to put the sun in the field of view of the imager. On the right side of this page, you can see a picture from the test. This is Johns Inc.'s test facility. You can see the test flare and the crane holding the extractive system above the flare. This is the performance from the perf test. And on the right, the table on the right, you can see our VISR results versus the extractive results. And you can see for high combustion efficiency above 95%, we're within 0.1% on average of the extractive results. And then as the combustion efficiency drops, our accuracy relative to the control method, the extractive method, is reduced. So we're very high accuracy for the upper combustion efficiency range, which is where you're going to be with your compliance point. And then as CE drops really low, less than 90%, our accuracy starts to suffer. But if your combustion efficiency is down at 80%, you have some significant issues with the performance of your flare, and the accuracy is not as critical. It's also, we can't tell from this VISR test which method is diverging here, because when the flare is not burning very well, then where you extract a sample with your extractive system is going to have a profound effect on the combustion efficiency number you get from the extractive result too. So all we can say here is that the two methods start to diverge when combustion efficiency is very low. But when you have good combustion above 90%, VISR method gives very good results relative to the extractive method. And the other significant thing we can say from the perf test is that we can show that our VISR method has no bias introduced due to distance or viewing angle, which gives us a wide range of deployment options for our continuous monitoring VISR system. No bias was shown due to fuel composition. Again, this is a blind test. We had no prior knowledge of the composition of what was being burned, or the flow rate, or the steam ratio, the combustion zone net heating value. So without having any knowledge about the process conditions, that's how these results were obtained. Putting the sun in the field of view had no effect on our results, nor did the time of day. The only environmental factor that had any bias showed any bias during this test was fog. When we had very heavy fog, it tended to put a small negative bias into our VISR result to the tune of 1 to 2%. So the perf test showed that the VISR method is not only very accurate, but also very robust. You can see the chart at the bottom is the extractive testing versus the VISR results across the entire perf test. So very, very accurate, very robust, very well suited for continuous monitoring. So some of the applications for VISR, the primary one that we had in mind when we built this was for compliance. We have the refinery sector rule that will become effective in January of 2019, which requires continuous monitoring of the flare. The rule specifies the indirect method. So what you would be required to do is to measure, use an online GC or a calorimeter to monitor your process stream, determine the BTU content of which you're sending to the flare. You would also need to monitor the pressure and temperature of that stream to correct to standard conditions. You then need to measure the BTU content of your supplemental fuel, pressure and temperature of that stream, and then whatever, if you have assist steam or assist air, you need to measure those as well, and pressure and temperature. Standardize all of these measurements and use them to calculate a combustion zone net heating value and maintain that above a certain level. That's essentially what the refinery sector rule requires. And you have to demonstrate compliance with this every 15 minutes. So these Rule 40s, Part 63, Subpart 670, B, C, D, E, and F are the regulations that will be covered by VISR. D, E, and F are the ones that define how to calculate the combustion zone net heating value. So this is an indirect method. You're basically monitoring what pre-combustion streams, and then you're making an assumption about the performance of your flare. VISR will replace this method and allow you to directly measure the performance of the flare. So essentially replace the idea of the combustion zone net heating value. You directly measure the combustion efficiency, maintain it above a 96.5% compliance point, and you're done with one instrument. Demonstrate compliance. And a significant benefit of using VISR as your compliance device is there's no latency to this instrument. So if you are in a situation where your flare is not at the proper combustion efficiency, you have time to react, you have time to add supplemental fuel, add assist steam, basically bring your flare into compliance within that 15-minute compliance period. With the indirect method, if you get out of a compliance zone, your online GC is going to have a sampling time anywhere from 6 to 8 minutes. So you might get 1 or possibly 2 data points within a 15-minute compliance period. Not a lot of time to react if one of those compliance points is below the requirement. So this is a great application for VISR. It's going to simplify compliance, reduce deviations, and allow for better optimization of flare reducing emissions, reducing the use of supplemental fuel, all around better solution than the indirect method. The other regulations that we're pursuing approval for would be Part 670C, which requires no visible emissions from your flare. This is like a method 22 type opacity measurement, so you either have visible emissions or you don't. And we believe the smoke index can be correlated to method 22 and used to replace this requirement. And then finally 670B requires you to have presence of a pilot flame, which we can also monitor with the VISR device. So this one device can replace combustion zone net heating value, the thermocouples monitoring your pilot flame, and whatever method you're using to ensure no visible emissions. This is something we're pursuing now with the EPA. We're pursuing approval, and we expect by the end of 2018 to have this method approved as an alternative test method. So this could not only apply to the refinery sector, but also the upcoming rules for the ethylene sector, the EMACT rules, which we expect out at the end of 2018 or early 2019. So a very capable compliance device, still need EPA approval, but we expect that very soon. It can also be used very capably as a control device. I mentioned that the Mantis device with the VISR method has no latency. So here is now, for the first time, a feedback system for your flare control. So this can feed control back to your DCS, tell you how well your flare is burning, whether you have any visible emissions, and that data can be used to put into closed loop control to control your supplemental fuel, your process stream, your supplemental steam or air, and operate the flare at what's known as the incipient smoke point, which is where you get the best combustion efficiency, but without any visible emissions, and do it in a control loop without the need for your operator to monitor it. So this is a possibility for VISR because of the fact that there is no latency in this device. So your performance is immediately fed back to your control system. And I should also mention that the device can be put on a pan tilt if you have multiple flares at a site, and you can actually share time between those flares. So even a single device could be a control system for multiple flares. This requires that you have a line of sight to, this is presuming you have a location you can put the device and have line of sight to multiple flares. Usually that's the case. So if you're controlling a flare with VISR, you're going to basically keep your flare between these two critical parameters, combustion efficiency and smoke index. You really need to monitor both because, for example, if you have a steam-assisted flare, you start to see smoke, you'll likely add supplemental steam to get rid of the smoke. But how much steam do you add? If you add too much, your combustion efficiency starts to drop. So you can view these two parameters, combustion efficiency and smoke index, as sort of lanes on the highway, and you're keeping your flare between these two lanes. Another application for VISR is to monitor temporary flares, especially if you're a refinery. You'll be subject to the refinery sector rules starting in January. If you have a turnaround planned or some maintenance activities planned that are going to require temporary flaring, that flare also has to meet the refinery sector rule monitoring requirements. It may not be practical to install all of the indirect methods on that temporary flare. So it's a great application for VISR. It could be set up very quickly along with the temporary flare and demonstrate compliance for that rule. We can also use this device for short-term flare studies if you have a need to measure flare performance to support a permitting effort or a performance test for a new flare, or just to learn more about the emissions from your flares or GHG emissions, inventory, whatever the need may be. This device is well suited for that application. It can be set up 10 or 15 minutes, and we're taking data, and there's no post-processing required. You get the immediate performance results. And if needed, we can capture short clips of 30 hertz raw data. If you're a combustion engineer and you really need to understand what's going on in the combustion zone, we can study the spectral data at a very high temporal resolution. It can be a very good diagnostic tool for a problem flare, or just to really understand the evolution of the combustion particular flare. So that is an introduction to VISR and the Mantis device, which is built around the VISR method. And what we're going to do now is do a demonstration for you. So I'll turn that over to our field group, and we're going to show you how this device works in real time. Okay, this is now the demonstration portion. And what you see here is our test flare setup. We have 3 tips on this flare. These are brush torches, and each tip really has been modified to have a different orifice, so it allows us to change the exit velocity and put the flare into a few different conditions. We also have a flare operator here, and we have the ability to change the flow rate. We can use propane, we can use acetylene. So those are our flare controls. We're going to use this flare to demonstrate the VISR method. So what you're looking at right now is a propane flame. This is a higher flow rate that we can send to the flame. And you'll notice a nice orange flame in the visible image. Combustion efficiency is quite high, 100%. And there's our smoke index, you'll see, is less than 1. They have no visible emissions here. And flame stability is in the lower 90s. So now we're going to change this flare, and we're going to increase the exit velocity. And that's going to give our flames are going to go away in the visible spectrum. If you look at the VISR data, our combustion efficiency is still very high. You'll see the flame generally becomes a little more stable. They expect the flame stability to rise over time once the flow rate equalizes. Still no visible emissions, so still our smoke index is less than 1. So now we're gonna cut this exit velocity by changing the flare tips. So we still have relatively high flow rate of propane. Now we're actually going to start dialing down the flow rate. And as we reduce the flow, reduce the exit velocity, you can see in the visible image we're starting to get a little smoke from this propane. So what's happening is the mixing is not very good at the flare tip. It's not enough oxygen, it's not fully combusted, and you see this in the VISR data immediately. You see the combustion efficiency dropping, the flame stability dropping, and our smoke index is going up. So now our smoke index is above 2, and if you look in the visible spectrum, you can see the wisps of smoke there. So what we're going to do now is add a little acetylene to this low flow, low exit velocity scenario, and what that's going to do is add some smoke. Some more acetylene is a larger molecule, requires more oxygen to combust, and so as we increase the acetylene, you start to see heavier smoke. This is immediately reflected in the VISR data. You can see our smoke index is almost pegged now, above 9. Our combustion efficiency down around 95%. And so now that we're blending propane and acetylene, now we're going to switch back to the high velocity tip. And that should clean up the smoke. So watch the smoke index and watch the combustion efficiency as we adjust the exit velocity.
the visible spectrum, you can see the smoke is starting to disappear. As we turn those tips off, now we're only on the high velocity tip. Again, no visible flame, but our smoke index has gone away. We're back to 100% combustion efficiency. But now this is a mixture of propylene and acetylene. So that gives you a good idea of the immediacy, the zero latency of the VISR data. How you can use both combustion efficiency and smoke index to operate your flare at the incipient smoke point, get the best possible combustion efficiency without any visible emissions.